This problem is really all about units. We will be using the ideal gas law, PV equals nRT. And in the problem, we have the volume given. We have mass of argon, which we can convert to the number of moles using the periodic table. R is just always R. And we'll also have temperature. So we will be looking to find pressure in one of those argon containers. Those are the big canisters that you can see hanging around labs sometimes. And apparently they contain 38 liters of gas. They are very, very heavy. But let's stick to the problem here. Pressure is nRT divided by the volume. For this equation to make sense, however, we need all the units to match each other. And when having a problem like that where all the units are a bit all over the place, and just in general, it's good to work with SI units. System, international system of units. Okay, so in this system, R is equal to 8.31 joules per mole per Kelvin. And then N, we need to find it in mole. Temperature needs to be Kelvin. Volume needs to be meters cubed and not liters. And that will give us pressure in Pascal. This joule here converts into Pascal and meters cubed, and that's how all those units correspond to each other. Okay, first of all, let's do temperature because that's one of the easiest one. 21.6 degrees Celsius. 21.6 degrees Celsius. We can add 273 degrees and it becomes 295. Let's just round it off. Yeah, let's just round it off like that. Okay, so the temperature is 295 degrees Kelvin. The volume, we have 38 liters. If you convert liters to meter, you will find a factor of 1,000. Alright. And then the hardest would be the last one, the number of moles. And so to find N, that's an ugly N. To find N, one needs to divide the weight by the atomic mass in gram per mole. So the weight here is 105 kilogram that we can divide by, for argon, this is 39.95 grams per mole. So we will run into another unit issue here. One way to solve that is to convert this kilogram into grams. And to do this, we need to multiply by 1,000. So here we have our 105 kilogram of argon, and then we divide by the atomic weight of 1 mole. This information can be found in the periodic table under argon. So you will find argon at AR, and below it you can find 39.95. I don't remember the atomic number up top, but the only thing that really matters is this mass, and that can be thought of as grams per mole. Excellent. So what is our number of moles then? If we divide this by this, we have 2,628 mole. Excellent. So now, placing all those numbers in this equation, we obtain a pressure of, and I didn't do this one yet, so I will run the numbers with you, but hopefully it should match the one from the manual. So what I have here is 1.7 times 10 to the 7 Pascal, or 1.7 times 10 to the 4 kilopascal, which is a unit we are most used to seeing. Let's see. In the manual now, what's the answer they give? One 1.69 times 10 to the 8. Alright guys, so there has been a problem because this should be 8, and I think the problem was in my math, so I am terribly sorry for this. Because when you actually do it right and put all those numbers together, what you will get is 8 here. And so this becomes a 5. Phew! That was close. And yeah, this is the answer you should get. 1.7 times 10 to the